Today we see about the advances in metrology. So this is the fifth unit of the metrology and measurements. So the subject code is 20ME601. So now we see about the topics to be covered for this lecture. The first one is interferometers and computer aided inspection and coordinate measuring machine and machine tool metrology. For the interferometers to measure the flatness of the measurand, and the laser interferometer and Mitchell's interferometer also discussed for this lecture, and computer aided inspection, the digital devices and machine systems. And next one, the coordinate measuring system also discussed in this session. And the machine tooled metrology, the surface roughness measurement and straightness measurement and squareness measurements. These things are discussed in this lecture. So now we go for the precision instruments based on the laser. So laser stands for light amplification uh, by stimulated emission of radiation. Laser instruments are devised to produce the powerful monochromatic collimated beam of light in which the waves are coherent. The development of laser gives productions of clear coherent light. The biggest advantages of this coherent light is that whole energy appears to be coming from a very small point. The laser beam can be focused easily to either a parallel beam or into a very small point by the use of lens. Next, we go for the principle of laser. The principle of laser involved the laser is when the photon emitted during the stimulated emission has the same energy phase and frequency as incidental photon. The photon comes in the contact with another atom or molecule in the high energy level E2, then it will cause the atom to return to ground state energy level E1 by releasing the another photon. The sequence of triggered identical photon from the stimulated atom is known as stimulated emissions. Next, laser metrology. The laser beam projected directly on a position detector is a method of alignment used in a number of commercially available systems, and laser is suitable for more general applications where a convenient or collimated and high intensity source is required. Precision, accuracy, and no contact and hard moving parts. Laser measuring machine. So laser measuring machine is the laser telemetric system and laser and LED based distance measuring instruments. So first one is laser telemetric system. So this laser telemetric system is used for measure the length of the object or distance between the object into the measured. Here the hysteresis synchronous motor and the motor drive and oscillator counter and edge sensing and photo deflector and the measurement region, the object to be measured. So here there are two windows. The object is in between, placed in between the two windows, and the light sources are laser source to pass into these two windows from the observer. The object is dimension to measured here. It is possible to detect the change in dimensions when the components are moving. It is possible. This is the major advantage of the laser telemetric system. So next one is the laser and LED based distance measuring instruments. This is very reliable because there are no moving parts. Instruments response time is milliseconds. The output is provided 0 to 20 megaohms. And next one is for profile checks. So here the object is placed and the beams placed between the uh, beam splitter. Here the laser light is passed to the beam splitter. The split lines, the monochromatic lights are is these things are recorded by the CCTV camera. So here the profiles checks for the object. Next one, the scanning laser gauge. Here the rotating mirror also is fixed between the uh, a scanner motor, and object also placed in between the linear scanner and photo cell. Here the light is passing through the linear scanner to the photo cell. It will be recorded to the and displayed after operator console. And next one, interferometer. It's a laser interferometer is involves the following components: two frequency laser source, optical element, and laser heads, measurement receiver, and measurement display. These are all the major components of the AZ laser interferometer. Here the object is placed in between the fixed and fixed and external cube. Uh, Fixed internal cube corner and external cube corner. Here the fixed internal cube corner have the beam splitter. These beam splitter lines are amplified and also to project the uh, distance of the object. So next one, optical elements. These are all the very beam splitter and beam benders and retro reflectors. And the beam splitter, it is used to divide the laser beam into the separate beam along the different axes. It is possible to adjust this beam splitter output intensity by having a choice of beam splitter reflectives and beam benders. It is used to reflect the light beam around the commerce on its path from the laser to each axis. The beam benders are just flat mirrors, but having the absolutely flat and very high reflectivity. And the retro reflectors, there are plane mirrors, roof prisms, or cube corners. The cube corners are the three multiply mutually, and the reflected beam is always partially these devices. And laser head measurement receiver, it is used to detect the part of the returning beam as f1, f2, and as Doppler shifted frequency display. This measurement display has a microcomputer to compute and display the results. These signals from the reference receiver and measurement receiver located in the laser head are counted in two separate pulse counters and subtracted.